Ever pondered on the intriguing question, what would happen if you dropped an egg from space? Well, let's dive into the science behind this hypothetical scenario and prepare for a mind-blowing exploration of physics and atmospheric pressure. Imagine if we could launch a fragile chicken egg into the cosmos. Sounds preposterous, right? But let's humor the thought for a minute. This egg, our tiny astronaut, would ascend past the troposphere, where we live and breathe, into the stratosphere, where commercial planes often cruise, and further still into the mesosphere, where meteors burn up upon entry. This is no ordinary egg drop, we're talking about an Eggstronauts journey into the stratosphere, and back. But what factors would influence the fate of our Eggstronaut? Enter the concept of terminal velocity. This is the constant speed that a freely falling object eventually reaches when the resistance of the medium through which it is falling prevents further acceleration. For a skydiver, that's about 120 miles per hour. But for our egg, the terminal velocity would be much slower due to its small size and relatively light weight. Now let's throw another curveball, into the mix: atmospheric pressure. You see, the atmospheric pressure decreases as we ascend higher into the sky. This means that our egg will experience less air resistance as it ascends, allowing it to reach higher speeds. But what happens when it starts its descent? Well, as the egg plummets back to Earth, it re-enters denser layers of the atmosphere. The increasing air resistance slows it down, but will it slow down enough to land safely, or will it meet a messy end, splattering on impact and leaving us with the world's highest omelet? So, are you ready to join us on this egg-sighting journey to the edge of space? Let's crack open the mysteries of the universe one egg at a time. Before we take our egg on its space journey, there's some groundwork to do. This isn't your average weekend DIY project. It requires careful planning, precision, and a touch of creativity. First up, protecting our precious cargo, the egg. The egg capsule needs to be lightweight, yet sturdy enough to withstand the harsh conditions of space and the plummet back to Earth. Many opt for a design that mimics the natural properties of an egg, as nature has already perfected the art of protecting this fragile life form. Some use a soft material like foam or bubble wrap to cushion the egg, while others create a more rigid structure using materials like plastic or wood. The goal is the same: an unscrambled return. Next on the agenda is tracking. We can't just send our egg into the stratosphere and hope for the best. We need to know where it's going and where it lands. To do this, we use a GPS tracking device, which sends live location data back to us. This way we can track our egg's journey from launch to landing. Last, but certainly not least, we have the vehicle for our voyage, the weather balloon. These aren't your average party balloons. They're made of a thin, flexible material called latex that can expand as it rises in the atmosphere. Filled with either helium or hydrogen, these balloons can reach altitudes of up to 30 kilometers. That's almost 3 times the height of Mount Everest. And it's not just about getting the egg up there. The balloon has to be able to bring it back down too. So it's designed to burst at a certain altitude, starting the egg's descent back to Earth. Now that our preparations are complete, it's time for the big launch. Every element of this experiment has been meticulously planned and prepared. From the protective casing, the tracking device, to the weather balloon, each component plays a crucial role in the success of our mission. So, buckle up, folks. The countdown to the extraordinary egg drop from space begins. With everything in place, we are ready to launch our egg into the stratosphere. The launch process is a spectacle in itself. The weather balloon, a seemingly delicate yet robust vehicle for our egg, is inflated. It gradually expands, filling with gas until it's a towering spectacle of anticipation. Next comes the critical part: attaching the egg. The egg, our brave astronaut, is nestled securely in its protective casing, ready for the journey ahead. The payload is then delicately attached to the balloon. With the payload secure, the balloon is released, and it begins its ascent. The sight is nothing short of breathtaking. The balloon carrying our delicate payload drifts upward, slowly at first, then gaining momentum as it ascends into the bright blue yonder. Excitement fills the air as we watch our egg, now a speck in the sky, ascend higher and higher. As our egg ascends higher and higher, we wait with bated breath for the thrilling drop. The moment has arrived. Our egg is about to take the plunge from the edge of space. This is the crux of our experiment, the moment of truth. The egg, housed in its protective casing, is released from the high-altitude balloon. It hangs for a second, suspended in the vast expanse of the stratosphere, before gravity takes hold and the descent begins. As it falls, the egg is subjected to the whims of the atmosphere. The wind speed and direction play a critical role in its trajectory. The higher the wind speed, the more it can potentially veer off course. The direction can also affect the horizontal distance it covers during its descent. But it's not just the wind that our egg has to contend with. The air density also plays a part in this high-stakes journey. Up here, the air is thin, offering little resistance. But as the egg plummets closer to the ground, the air becomes denser, slowing the egg's descent and increasing the pressure on the protective casing. And speaking of the casing, its design is paramount to the egg's survival. It has to be sturdy enough to withstand the harsh conditions of the stratosphere and the impact of landing, yet light enough not to add unnecessary weight to our payload. It's a delicate balance, a testament to the marvels of engineering and design. As our egg continues to fall, it's a race against time and elements. Each second brings it closer to the ground and the tension builds. Will our egg survive this daring descent, or will it end up a scrambled mess? The descent, from the release to the landing, is a journey fraught with challenges. It's a test of resilience, of design, and of our understanding of the forces that govern our world. It's a spectacle, an experiment, a lesson in physics and engineering. Our egg has made its daring descent, but what's the result? Did it survive the fall? This is the question that hangs in the air, just like our egg did moments ago. But fear not, for the answer is just around the corner. The egg has landed. It's time to uncover the results of our experiment. We've just witnessed an egg plummeting from the stratosphere, a journey that few eggs or even humans get to experience. But what has become of our brave little astronaut? The first step in revealing the fate of our egg is locating it. You see, dropping an egg from space isn't as simple as letting go and watching it fall. The egg could land anywhere within a several-mile radius, depending on factors like wind speed and direction at various altitudes. To assist in the retrieval, our egg was equipped with a GPS tracker. Now, the moment of truth. The recovery team has reached the landing site. The egg container is intact, but the real question is, did our egg survive the fall? And the answer is yes. Our egg has successfully survived its voyage from space, unscathed and ready for an omelet. This remarkable outcome wasn't just a matter of luck, it was the result of careful planning and innovative design. The protective container, designed to absorb the impact of the landing, played a crucial role in ensuring the egg's survival. But let's not forget the forces that were working against our egg. The gravitational pull trying to smash the egg into the Earth, the atmospheric pressure changes, and the bone-chilling temperatures of the stratosphere. Our egg braved it all and emerged victorious, a true testament to the power of science and engineering. So while our egg has had quite the adventure, it's important to remember that this experiment is about more than just dropping an egg from space. It's about testing theories, pushing boundaries, and learning from our successes and failures. It's about the spirit of exploration and the quest for knowledge. So there you have it, the results of our egg-sighting space experiment. Until next time, keep wondering and keep experimenting. So what can we learn from our egg space adventure? Our Eggstronauts' journey from the edge of space back to Earth offers us several key insights. First, it illustrates the power of innovation. With the right protective measures, even an egg can survive a fall from the stratosphere. This underlines the importance of thoughtful design and careful planning in scientific experiments and, indeed, in all problem-solving scenarios. Second, it underscores the significance of curiosity. Our egg drop experiment might seem whimsical, but it's grounded in the same spirit of inquiry that drives all scientific exploration. It teaches us about gravity, atmospheric pressure, and the thrill of testing hypotheses. Finally, it highlights the value of experiential learning. Hands-on experiments like this one help us grasp complex concepts in an engaging and memorable way. They encourage us to ask questions, make predictions, and seek answers. Remember, the sky is not the limit, it's just the beginning. Keep exploring.